But what's going to happen here is that your sine values for theta, when we're looking at this theta value, instead of saying, 420 degrees or 900 degrees, whatever it may be, we're not looking for that angle. We're looking for the angle that's going to have a sine value that's somewhere in between these two quadrants. Okay? Because if you look at these two quadrants, you are able to see that the sine values are all positive in the first quadrant and they're negative in the second quadrant. So your reference angles are always going to be within these two quadrants for sine in order to figure out what theta is. I'm going to go through the rules with you first, and then I'm going to show you the examples of how it bounces just within those two quadrants. It is actually quite simple. You still got to know your first quadrant, though, okay? So cosine then, your cosine inverses for theta are always going to be within the first and second quadrant. Once again, if you think about your cosine values are always positive in the first, negative in the second. Remember, they mirror themselves going back and forth. The second quadrant cosines bounce off your x-axis, so you're able to get your reference angles that way. All you're doing is trying to figure out the reference angle here. Okay?
And the first quadrant has either side.
Yeah. And then, once again, these theta values, let me flip to the next screen here. These theta values for cosine are always going to be between, between 0 and pi, or between 0 and 180. Okay. Because when you find these, you're going to be looking at them between positive and, or between degrees and in radians. And like I said, as I get into some of the actual examples, after I get the rules up here, it makes more sense. Yeah. Yeah, because if you look at it here, everything's positive in the first quadrant. For cosine, it's negative in the second quadrant. They are, but what happens here is that you're just looking to get the reference angle, and it's easier just to get a quick reference angle in here than sometimes bouncing back and around. Because this, by keeping everything between 0 and 180 for cosine, you're encompassing all possible values. Okay? You're going to get all your possible values. Because as you get into the third quadrant, the cosine values are all the same as they are in the second quadrant. Because they just mirror themselves. It's the same reason why we don't worry about the sine values in quadrant 2, because they're all the same as the first quadrant. Where are they going to be different? Between 0 and 180. Then they just start repeating themselves. They're just looking to group them in a singular area. That's all. And then tangent is also between first and fourth. The inverse tangent is going to be between your quadrant 1 and 4, but it no longer can equal pi over 2, because if it was at pi over 2, 90 degrees, remember tangent is y over x, you're dividing by 0. Same thing when it's down at 270. It's negative 1 over 0. It's undefined. That's why they don't put less than or equal to anymore. So it's between negative 90 theta and positive 90, or negative pi over 2. Where the values are, yes. Except that it cannot equal pi over 2. Because you divide by 0. Okay? Now, with these rules, what happens when you look at the actual problems that we're going to have is that you're going to see something like this. And it's going to ask this very simple question. This is what all the wording means. You're going to see inverse sine of root 3 over 2. That's going to be the question in the book. What that means is what angle has the sine that equals root 3 over 2. So you think about your ordered pairs. when you're dealing with your ordered pairs, remember, 3, 2, 1, 1, 2, 3. Your sign values are always the y coordinates. These are your x coordinates, these are your y coordinates. Which one of those has the root 3 over 2? The 60 degree. Correct, that's my 60 degree. So that means my theta equals 60 degrees, or what's the radians? That's what that means. Okay, that's what it means. If this question asked you what was the sign inverse of negative root 3 over 2, well, if it was negative root 3 over 2, that means it was down in the fourth quadrant, and the negative root 3 over 2 was the first angle, and the first angle with the negative root 3 over 2 was the 30 degree. Does that make sense where it's coming back and forth like that? Yes. That's what we're looking at. Okay. Well, it's negative, so it's a different answer. Okay. All right. Let's try another one. Cosine inverse is equal to 2. Cosine inverse is equal to 2. So that means what angle, when you take the cosine, gives you 2. Well, think about your ordered pairs. 3, 2, 1, 1, 2, 3. Do any of those ordered pairs have it equal to 2? No. So that means this is undefined. There's no answer. It's undefined. No ordered pair gives you a cosine, or no angle is going to give you a cosine of 2. What's that? In this case, it's going to ask you to find one angle that's in degrees and one angle that's in radians. You'll get one of each. Okay. If this asked you what was the secant of 2, what is the inverse function of secant? Cosine. So if you see secant of 2, that means you're going to look for the cosine inverse of 1/2. Flip everything around. Okay? So that's when you start looking for which one has the cosine of 1/2. Well, 3, 2, 1. 60 degrees, or pi over 3. All right. Tangent. Inverse tangent of -1. Inverse tangent of -1. Well, in order to get inverse tangent equal to -1, that means when you have tangent, you have y over x. You agree? In order for y divided by x to equal -1, doesn't y and x have to be the same? All right. What sets of ordered pairs? 3, 2, 1, 1, 2, 3. What set of ordered pairs are the same? The root 2's over 2's. Do you agree? Root 2's over 2's being at what angle measure? 45. Now, they're both positive here, which means, where are they both negative? At -45. They're not both negative, excuse me. One of them's negative. There's 2 and negative. Okay? Fourth quadrant has one positive and one negative. So that means at -45, or what's 45 degrees in terms of radians again? Pi over 4. So it would be -pi over 4. Once again, all I'm looking at here is I'm looking at a reference. I'm just going to a negative reference angle because I just go down. No, remember, your parameters, you always want to be within these parameters. They're going to tell you what parameters to be in. Okay, they're going to tell you. Exactly. Yeah, Vanessa. Uh-huh. Yeah.
1/2.
Here, yes.
Okay, so that would be very.
That's for this part here. This is a different problem. I just made it that up. This cosine of 1/2, is that what you're talking about?
Yeah, okay, well, yeah. No, the secant of 2, I'm talking about that.
Yes, secant of 2. Secant of 2 is the same thing as saying cosine 1/2.
Which is 30 degrees.
Cosine is at 1/2 at 60 degrees. Remember, it goes because it cosine sine. All right. Remember, cosine comes first in the alphabet. X comes first in the alphabet. All right. This is gonna take a little while to get used to this. All we're doing is working backwards. What time is this one work? 18? Sweet. We got plenty of time. Let's do some more. We're not going to do them all right? Don't worry. Let's do tangent of root 3. Inverse tangent, square root of 3. Okay, so what you're asking to find here is what angle has a tangent of root 3. So, in order to get a root 3, in order to get a root 3 for tangent, that means it's either going to be 3, 2, 1, 1, 2, 3. What angle can we throw out? The root 2's. I know I can get rid of these. These aren't going to work because they have root 2's and 2's. Do you agree on that? Yeah. Tangent is y over x. Which means I have to figure out which one of these ordered pairs, when I take y divided by x, will I get root 3. Well, to get just root 3 in the numerator, if I look at the 60 degree, I have root 3 over 2 divided by a half. Do you see that? Root 3 over 2 divided by 1/2 is root 3 over 2 times 2. That's where you get just plain old root 3. You're using logic here to figure out which one of these guys is going to get you just a root 3. Y over x. Root 3 over 1. Because the denominator dropped. So this is going to be at 60 degrees, or pi over 3. Hopefully not as scary. Okay, what was the next one? Cosine inverse root 2 over 2. Well, that one should be easy.
Did you say root 2 over?
I did.
Isn't that already?
It is. What angle is that? 45. Or pi over 4. What angle has the cosine? What angle has the x value? Root 2 over 2. Pi over 4.
Are we going to use this way?
Are we using like a note card?
No. There's calculator, non-calculator part.
There's so much to remember.
All you need to know is that first quadrant. Right?
And what's the
Sine of 1/2. Who has a sine of 1/2? Who has a sine of 1/2?
Wait, it is y. Wait.
Sine is y. 30 degrees. 30 degrees or pi over 6. Okay?
Wait, I didn't know was there to be things like that. What if you give something like, I don't know, cosine inverse of 22?
If it's cosine inverse of 22, you're going to use your calculator. You use your calculator, second cosine 22, hit enter, you're going to get a decimal. And that's the second part of this lesson. This is where it brings back from geometry. You're going to get theta, a right angle, a 4, and a 7. What's theta? What trig function am I going to use here? No, I got to find theta. I got to find the angle. Sorry. Sine. So I know that the sine of theta is 4 over 7, which means theta is going to equal the inverse sine of 4/7.
Wait, what? What?
You did that in geometry. You hit buttons on your calculator.
Okay.
Okay?
Are you gonna like close that?
Second sign, 4 divided by 7, hit enter. Poor Vanessa is ready to throw something at you. What's up?
For the sign of, your sign of half,
Mhm.
there's two, there's one at 30.
Which one is the y value? Sine is the y value. Which one has the y value of 1/2?
It's sign of.
Sine is opposite of hypotenuse.
So you get number that too.
Yeah. So we told.
Yeah.
Here's what I want you to try tonight.
Yeah.
That's what I'm thinking.
It's cool class, but don't like
Wait, that is cosine and x.
Yep. I want you guys to try these. These first 8. Hey, the first 8 problems are exactly what we did just now. The next group is all using buttons on your calculator. Second sign, blah, blah, blah. Get a decimal, things like that. You should be able to fly through that. You've done it before. There are examples of how to do that in your book. I didn't show that many examples of it because I'm banking on the fact that you remember something from geometry. Please, I'm hoping you remember something from geometry, okay? One thing I'm going to remind you, please, 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 know your first quadrant of the unit circle, guys. Know that first quadrant. If you memorize that, the rest of this is a piece of cake, okay?